and welcome to Learning Rust Programming series. My name is Ashish and today we are going to learn to create custom data types using struct and enum. In Rust, a struct, short for structure, is a composite data type that allows you to group together variables of different types under a single name. It's a way to create your own data types with the custom fields. Let's take an example. So I'm creating struct with the name person. I'm going to create ID and name with parameter string, and last city with the parameter string again. Let me use this structure in our program. So we have to use curly braces in order to initialize my structure, then name and city as data type string. So I guess we forgot to add. So we have added this person object. Now let's print. Now to print, we are going to use positional arguments. We have three variables: p dot id, p dot name, and last p dot city. So this is how we are going to access our ID, name, and city from this struct object, just like C++. Yeah, so you can see it has printed. Now next we can also have structure of tuple. So let's say if I create structure name, which has two, which is consist of string and string. So this structure is actually first name and last name. Let's assume. So I can initialize it like this. So I can use name equal to, sorry, it's a variable name equal to name, and I need to pass. Yes, you are right. So we need to pass this string. So just difference is that here we'll have John and here we'll have, and we can use like this. So in order to use, if I want to use tuple, then I need to use it like this. So name dot 0 and name dot, okay. So if I run this, yeah. So now what if I want to use this structure, tuple structure in my another structure? So I can reuse this structure inside my this structure. What I have to do is I need to change this data type as name. All right. And what I need to do is, what I will do is I will shift this name to here, and I can use this variable as this. So one more thing what I can do is I need to add parameter now. So p.name.0 and p.name.1. It's because now I am accessing. So what do we have is, so p.name is our tuple, and inside that tuple I need to access 0th element. Correct. So that's why p.name.0 and p.name.1. Now if I run this, yeah, so you should see the same result. Now instead of using p.0.name1, what I can do is I can use destructuring technique in Rust. So we can destructure this complex struct object like this. So suppose I have this name, right? So I have this person already defined here. What I can do is I'm going to create destructuring like this. I'm going to name it as a pk, then name. Inside that I'm going to name it like first and last, and last we have ct as ct, and we are going to assign it to our object p. Now we have used destructuring technique. Now whatever variable names we have specified here, pk, first, last, and ct, we can use them as it is in our print statement. So here on we can use these variables. So this is going to be a first, this is going to be last, and this is going to be ct. And if I run this, so it has printed. So it has given me a warning. So I can use now, you can see non-shorthand field pattern, right? So what I'm going to do is now we can use shorthand technique. So here you can use, I have given name equal to name, city equal to this thing, right? So what shorthand technique tells you is it is also called as field init shorthand. And if parameter name and struct name are same, then you can omit one of the things. So like this, I will show you. If I have id equal to 1, then I have already defined name, and then I have ct equal to let me copy it. Okay, so what I can do now is I can simply omit all these name parameters, and I will keep just variable names as it is. So it's a shorthand, and this is the way I can actually use. Okay, so this is a shorthand technique. All right. So in the person struct definition, we use the you could see we have used the string data type rather than using and ampersand str string type, that is slice type. This is deliberate choice because we want each instance of the struct to own all of its data, for that data to be valid for as long as the entire struct is valid. There is a concept of ownership in Rust that we are going to learn in next video. It's also possible for structs to store references to the data owned by something else, but to do so, it requires the use of lifetimes, a Rust feature that we'll discuss in next. As I said, lifetime ensures that the data referenced by struct is valid for as long as the struct is, let's say, if we try to store a reference in struct without specifying lifetimes, then we are going to get compile time error. So the compile time error is like missing lifetime specified. All right, so let's move to enums. In the Rust, the enum is short for enumeration, is a type that represents a value that can be one of the several possible variants. Enums are a way to define a type by enumerating all its possible values, which can be different types themselves. Enums are particularly useful for situations where a value can take on different forms or states. Here is a basic example of struct. So let me clear it. So to define enum, I'm going to use keyword enum. I have, let's say, direction. So I'm going to create north, south, east, and west. All right. Now to use this direction in my example, so you can see I have not specified type of this. Uh, uh, like in struct, we used to give data type over here for that, for the each subtype. But here I'm not specifying it. So how can we use it? Direction dot, say, north or maybe east. Okay, and then we can use match keyword. Match is like switch keyword in C or Java, and where we are going to do a match for all condition. Direction dot north, use arrow key, and we are going to print then that moving. So it's equal to not. So we need to provide all four possibilities. And here it's not semicolon, it's a comma. That's why it's complaining. North, south, east, and last is west. All right. So all four have been used. Let's run this. So we are getting moving east. Okay. So you can ignore this warning for now. You need to add one directive that this is being unused. Okay. So let's move ahead. So this example, we define enum call direction, as I mentioned, with four variants, that is north, south, east, and west. We create an instance of direction enum called player direction, and we set it to north variant. Sorry, east variant. We use a match statement to perform different action based on variant of enum. Now we can have enum with a variant with data. So suppose I have enum coin, which the value variants are like penny, then nickel, then dime, and last is quarter, but this is a variant associated with 32-bit integer. Okay, so now I can have, what I can do is I can have function value in cents, which takes parameter coin and which returns in unsigned integer 32-bit, and then I have match case here. It's penny, then it's going to return 1 match coin. Yeah, so coin variable coin. Okay, pennies here, then we have 4 variants. Nickel is, let's say, 5. Now I have, then we have time, its value is 10, and if it's a quarter, now here I'm need to pass value, it's value, whatever value we have. Okay, now let's come to this exam in main function. Yeah, I need to rename this to coin. Sorry for the typo. Yeah, here what I'm going to do is, let me create variable which uses each of this variant. Nickel equal to coins. Nickel time equal to coin. Time and quarter is coin. We have quarter and we are passing value as 25. Okay. And we print use macro. So value of a penny is how many cents? We are going to call function value in cents, and we are going to pass penny. Yeah. This way we can have the value of a nickel, and we are going to pass nickel. Then value of a dime, we are going to pass dime. Value of a quarter, we are going to pass quarter. Yes. All right. So we'll run this now. So you can see 1 cent, 5 cents, 10 cents, and 25 cents. So yeah, in this example, coin enum has variants like penny, nickel, diamond, quarter, where quarter has an associated value indicating its worth in cents. The value in cents function, this function uses pattern matching, as we have seen in previous example also, to matching the exact type and extract return the value associated with each variant. Enum in Rust are powerful and provide concise way to express complex data structure and state machines. They are more readable, you can see here, and they are widely used in Rust code, especially in scenarios where a value can take on multiple forms or where finite set of possibility exists. So this was about enums and structures in a simple language. So if you have any doubts or if you have any suggestion, you can comment on the comment section of this video, and we'll see you in next video. So thanks for watching. Please like, share, subscribe for better reach. Thank you.